Hello and welcome to part 3 of our Introduction to PA Systems. In order for you to understand what we're going to cover in part 3, it's strongly recommended for you to have watched and understood parts 1 and 2, which covered up to and including the concept of having to set different gain levels for different sources connected to a PA mixer. In part 3, we'll look at how you connect sources to the mixer and how you set the gain to an appropriate level for any given source. Also, for a change, we'll be using some real photos and active video clips rather than just my slightly dull diagrams. Also, one thing which I omitted to emphasise in part 2 is that the mixer or mixing desk really is the nerve centre of most PA systems. These days, many systems use what are known as digital mixers, which have complex, built-in, computer-like control circuitry. But for learning purposes, it's best if we start by covering the basics using an analog mixer such as this one. I feel duty-bound at this point to say a big thank you to my brother-in-law Robert Pyatt for lending me this handy little mixer for the purposes of this video. Okay, let's consider then that we've got a source that needs to be set up on the system. How do we go about it? Well, firstly, we need to decide which input channel we want to connect it to on the mixing desk. On most mixers, this can be pretty much any available channel, and ultimately the choice is yours. However, you'll generally need to bear in mind what other sources, if any, are already connected, what other sources, if any, you're going to add later, and then make your choice accordingly. Also, with this particular mixer, it has 6 conventional mono input channels with either Xlr or jack inputs, plus 4 other jack only input channels, which can be either stereo or mono. We're going to ignore these last 4 for the time being. For our first example, we'll consider a microphone source. Microphones almost invariably come equipped with a 3-pin Xlr connection like this. This is the most common form of connection used to connect sources to mixers, and as you can see here, the mixing desk has sockets of corresponding 3-hole type. To connect the mic to the mixer, it's a simple matter of using a suitable cable to connect one to the other. The cable for this purpose is one of these, an Xlr cable. The usual configuration for an Xlr cable is that it has a 3-pin plug at one end and a 3-hole socket at the other. Rather handily, this allows them to be extended one to another to make longer connections. In this instance though, we're just going to use a single cable. The microphone, having a 3-pin connector, attaches to the 3-hole or socket end of the cable like so, while the 3-pin plug end of the cable plugs into the 3-hole socket of the chosen input channel of the mixer, which I will do in a minute or two. Firstly though, you may be wondering at this point, why 3 pins and 3 holes rather than just 2 pins and 2 holes? Surely we just need one to carry the audio signal and one to act as the ground connection, don't we? Well, the sort of microphones and other sources used in most PA setups actually produce a signal on 2 of the 3 pins, with the other being the ground connection. Importantly though, the 2 signals generated are of opposite polarity to one another, one referred to as hot, the other as cold. When the signals reach the mixer, the input circuitry flips just one of them so that the signals are then of the same polarity. The result of this is that any signal interference picked up along the length of the connecting cable gets cancelled out, while the original signals generated by the source strengthen one another. A rather nifty little trick that. Also, regarding plugs and sockets, it's worth mentioning here that audio connectors are often referred to as male or female. For reasons which it would be indelicate of me to expand on, Plug or pin connectors are referred to as male, while socket or hole connectors are called female. Here are some examples of male connectors. And here are some female connectors. Right, we've just connected one end of our Xlr cable to our microphone, and we were about to connect the other end to the mixer. However, before connecting any source to the desk, there's something very important that we need to do. Set the gain knob and the fader for the input channel concerned to minimum. This avoids the occurrence of any nasty bumps or thuds through the system when we make the connection. Now the connection can be made safely to channel 1 in this instance. So that's our mic connected to the mixer. Now we need to set the gain to a suitable level. To do that, we need to present a suitable sound to the microphone for level setting. Traditionally, the words 1 and 2 have been used as they contain a useful spread of high, mid and low frequencies. However, I have heard D used instead, which is just as suitable. Also, if, unlike here, the mic and mixer are far apart from one another, you'll need a willing assistant to provide the required vocal signal. In this instance though, with the mic and mixer close to one another, I can do both the speaking and the tweaking. Now, in common with pretty much all mixers, this one has a level meter consisting of a 2-column array of LEDs. The LEDs are mostly green, but with some yellow and red ones at the top. Ordinarily, the level meter shows the overall output of the mixer, but if we engage this Q switch here, then the left-hand column of LEDs shows the input level of the channel or channels being tested. This mixer is a bit atypical in that it only has the one Q switch. Most mixers have a separate Q switch for each input channel, and it's often labelled PFL rather than Q, with PFL standing for pre-fade listen, which refers to the fact that it allows monitoring of the incoming signal before its arrival at the fader. Another way in which this mixer is a bit atypical is in the fact that when the Q switch is engaged, it doesn't allow for pre-fade monitoring the headphones, just visual level monitoring on the left column of LEDs. So we've got our gain set to minimum and our input and output faders down. If I pick up the microphone and start presenting a solid D sound whilst turning up the gain, then we should start seeing a signal registering on the left column of LEDs over here. I've got the Q switch engaged already, so let's demonstrate that now. D, 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 nothing yet. D, 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 just starting to get a signal. D, 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 D. We're just lighting it to the top of the green LEDs, so we've got about the right level that we want. D, 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 D. That's excellent. So we've set our gain for that channel, and so now we can move on to our next source. For our next source, we'll have an instrument. In this instance, it's going to be a keyboard, although it could just as well be a guitar or any other instrument with an audio output socket. Now, I don't have ready access to a full-size keyboard here at home, but this mini keyboard will serve to demonstrate how to set one up. Unlike most microphones, most instruments do not have a balanced line output. Some keyboards do, such as shown here. Instead, they usually have one or more unbalanced jack socket outputs. Unbalanced connections are only really suitable for short cable runs, say 3 meters or less. For longer cable runs, we need to convert to a balanced line. This is achieved using a DI box. DI stands for Direct Inject. I'll be covering DI boxes in more detail in a later chapter, but basically a DI box converts the unbalanced jack input to a balanced line XLR output. We can then use the familiar Xlr cable type to connect from the DI box to the mixer. And as it's now a balanced line signal, we can use as many Xlr cables as necessary to reach the mixer. It so happens that here at home I've only got one Xlr cable, so I'll be using the same actual cable which I used earlier for the microphone. Also, as I'm using a mini keyboard with a mini jack output, I'm using a special cable and adapter to connect to the jack input of the DI box. Let's just connect to the keyboard. And then the 1/4 inch plug plugs into the input socket of the DI box. Usually for a normal keyboard or guitar you'd use a conventional jack lead with a 1/4 inch jack plug at each end. With the keyboard connected to the DI box, I now need to connect one end of my Xlr lead to the DI box output. I also need to turn the gain to minimum for the channel that we're going to use. In this instance it'll be channel 2 on this desk, and ensure that the fader is on minimum as well. We're now ready to connect that end to channel 2 socket on the mixer. Now to set the gain level, I'm going to trigger off a demo audio output on the keyboard using this button here, and with the Q switch engaged on the mixer you can already see that we're getting some level over there even with the input set to minimum. Keyboards and guitars often produce a higher level signal than a microphone. But okay, we can now gradually tweak the gain up, watching the level meter until we're just lighting all of the greens. There we are, that should just about do it. About there, might get the odd flicker from the yellow. Now we have correctly set the gain for that channel. A little bit more, there we go. That's now correctly set. Well, that's about all for this chapter. To recap, we've looked at how to connect a microphone and electronic instruments to the mixer, and how to set the input gain for such sources. On the way, we touched on the role of the DI box, the principle of the balanced signal line, and the common types of connector typically used in PA setups. In part 4, we'll probably be covering things like equalization, phantom power, mixing desk outputs, routing of input channel signals, and grouping of input channels. I say probably because at the time of recording this part 3 I haven't necessarily finalised what's going to go in part 4, so it could all change. What fun, eh? Anyway, thanks for watching. I do hope this has been useful to you, and hopefully you'll be keen to join me again for part 4.